Our company, in short, we are integrators. We take systems from other suppliers in conjunction with our own technologies, and we put it into a process for laboratories and for sample handling at the mine sites for the usual factors: greater productivity, safety enhancements, improved quality, those sort of things. So I was the person who asked that question. What is the first factor you look for when you decide not to automate? And I'm not surprised to hear about, what's my payback, because generally speaking, we're all prepared for that. But what is interesting is what is the most common resistance that we hear? What's the most common factor that we face when we're looking at automation at sites? And it isn't the cost side, because usually companies have decided if they have budget or not, or if they believe culturally in automation or not. It's maintenance. It's maintenance risk. It's risk of the unknown. And I have to emphasize that we must share and empathize with people who have that fear. I don't know how many people here can put their hand up and say they could open up a cabinet, a control cabinet, in their operation and look inside and understand what's going on and do something with it. Chances are practically no one in this room. It is a black box within a black box, okay? So people who are in an existing mine operation, and I'm not just speaking about the labs, I'm talking across the board, are not necessarily familiar at all with this type of technology. So it's a very specialized person that you typically have to have on site who's going to handle this maintenance. And are they an accessible resource all the time? What happens if they go away on vacation for 4 weeks? Who's going to be dealing with my system? If something fails, I can't duct tape that. I can't ask the chemist in the lab to go find another type of reagent to get sort of the same results. Somebody has to handle the maintenance, and this is the primary thing that we face, and I think as a supplier in this sector, we have to take it seriously and find good ways to make people comfortable and have actual access to people and resources to manage these risks. Now, the ticket with this, why is it that alone, that hardware in and of itself is not sufficient to the cause? It's because automation requires something underneath it, the backbone, to give it direction, to compile data, and to use the information that automation produces in a wise way, okay? This is where IMP has introduced a software called Control Track Maintenance. Control Track itself is a software that has two aspects. We've got a LIMS, Laboratory Information Management System, which collates and gathers data from all the different instruments and processes within the laboratory. And that works with our Control Track Maintenance System, which tracks the performance of the equipment, the inventory of parts for the equipment, the history of the record of maintenance on that equipment, so you can optimize the maintenance records, you can do preventative maintenance, and you can schedule inventory control on your parts. I look at it this way. Automation is simple if you just look at a robot. Robots are cheaper now than they ever used to be. You used to spend $300,000 for a 6-axis robot. Now you can get one for $70,000, $80,000. But robots are being manipulated now by kids who are 8, 9, 10 years old in schools. The ticket is what the robot does in a proper way and the information that you gathered by using the robot. And that's where the backbone of Control Track comes into play with this virtual reality technology. So CTM, Control Track Maintenance features, it enables review, planning, and monitoring of all real-time performance, maintenance, and inventory aspects. Okay, it's helping out your people on your IT and maintenance team. It has preventive maintenance, logging, and tracking. Multiple laboratories can be managed from a single point. So if you have 5 or 6 and you want a consistent level of quality and inventory and parts control, you can get that through this system. Modular by design and expandable beyond the lab, which is a really neat thing because we started asking questions. Well, what about the services? What about the chillers, the dust control systems, the makeup air units, the HVAC, and that? All of that can be incorporated as part of the Control Track Maintenance System. Let's go a little further out in the sample receiving and reception area and those things. Can those be included? Yes, they can. So it's all dependent on the backbone of information that you provide with this, and all you need is an interface and the equipment you want to include within this platform. This is an IT person's dream. Basically, all we're saying here is that CTM is a cloud-based technology. It interfaces with the LIMS, and it doesn't have to be our LIMS. It can be Labware or AssayNet, which are off-the-shelf systems that you can use. And with that, it produces reports and functionalities real-time on screen or in collating data for operators, for management, for whoever is going to find value and use the data for valuable decision making. Just an example of a few of these, that's a typical dashboard here. You can use any of the functions to produce graphs or tables that, on display that are important to you as your process carries on. Breakdown modules, real-time breakdown logging, statistics, and messaging. You know, how frequently are we having breakdowns with this type of equipment? What have been the solutions we've applied to fix that? And do we need to do something different? Report modules. That's a fully customizable report generator. So someone in management who wants to get an understanding, how much are we spending on fixing equipment within this maintenance platform? What about the spare parts inventories that we have on hand? Do we have too many? Can we share them with another site? All of those features and more can be in the functionality of the report platform. Spare parts inventory, usage and reliability. So not only tracking what you have, but the time that your spare parts have been put into play and how long they've lasted and how reliable they are, for example, if you've switched from one supplier to the next. Once that is all in place, and there's a number of different modules, you can choose the ones that work for you, and that's the beauty of software technology today. It's not all or nothing. It's quite simple to use. It functions on Android, Windows devices, tablets, and you can use them on a phone. There's barcoding functionalities that incorporate with this to enable equipment scans for maintenance tasks as well. So it's got a broad platform of technology it can be used on to interface with humans. I have 2 slides left. This is the summary. Basically, Control Track Maintenance is a software that gives superior tracking on maintenance and parts and gives you tools to plan maintenance and get support. The key aspect for us here is that in 2019, combined with VR technology that we showed with that Microsoft Remote Assist, we'll be providing on-site service capabilities that are fast and efficient. You're not flying in somebody from the middle of nowhere when they're not traveling someplace else doing maintenance work. Now, it's going to be probably the summer of 2019. Everything's ready to go, but our techs are just waiting for the next generation of goggles from Microsoft here. And they just don't want to jump in yet. They see something really great coming on the horizon. So that'll be ready in February, and then the whole platform ready in the summer. One last note, future benefit. You can incorporate new sensor technologies and data to provide better information for predictive maintenance and for production planning in the laboratory. This is data from a vibration sensor on a pulverizer. And it's measuring vibrations in 3 dimensions. It's in the X and Y direction because the grinding vessel travels in a ring and puck structure in a X and Y back and forth direction, more or less elliptical. And then in the Z direction, which is up and down. So you got to think of the old top-loading washing machines. When it was moving around and around, that wasn't so bad. But when it started hopping across your laundry room floor, you knew you had a problem in the Z-axis direction. So these sensors on the pulverizers are able to track the vibration changes as a sample is introduced to the pulverizer at the left, what the vibration program looks like when you have big particles going through, a change in behavior when you get down to a particular grind, a smooth run yet to be defined. This was done with our partner supplier at Herzog in Germany. What the vibration pattern looks like upon discharge, and then the cleaning stage. What's really great about this is not only will it enable us to do predictive maintenance on a grinding vessel and watch the change in the vibration patterns over time and watch as it starts to look like it's getting to a failure point, but now you can customize the grinding on the basis of the ore body that's coming through and the sample type you're going to see. And that means you're going to extend your bowl life and you're going to get more consistent output on your pulverizer before it goes off for assaying technology. So that's a case where the sensor technology applied in a great way with your CTM and your LIMS system can give you valuable data. That's all I have for today. I'd love to talk to anybody who wants to come up and see me afterward, but thank you all for your time and enjoy the rest of the afternoon.